All right, good. We're live. Cool. All right. Let's see. How is everyone?
Hello. Doing good.
Awesome.
Stressed with midterms.
Yeah, it's that time of year. Well, hopefully the midterm for this course is not a super big deal. It's going to take time and effort to complete, but my goal with the midterm is to see people's grasp of these concepts and ability to use those to write code. And for the midterm, right, you just want to do what you can, pace yourself. There's questions that are worth different numbers of points. So if you see, a 10-point question that you're pretty sure you can do quickly, do that one. If you see a 10-point question that you have no idea how to do, don't spend time on it. Right? Go to a different question and then come back if you have time. I don't think it's going to be any surprises, right? I mean, the questions are very, very similar to things you've been doing in one-day programs and in the larger programming assignments. So if you're good with those, you should be good. Yeah, go for it.
When it comes to the midterm, are we looking at actually doing questions, or are we coding for all of these questions?
You're going to be coding for these questions.
Okay.
Sometimes I put in like some short answer questions and such. I did not do that for this one. I'll do that on the final because we'll have gone through more of the Linux side, more things about concepts in Linux and such. So on the final, there'll probably be a mix of questions. But for the midterm, we're just going with some bash coding and some C coding. And there's some questions where I'll ask you to write a complete program. There's some questions where I might ask for a function. There's some questions where I might ask for one or two lines of code, and so it's a mixed bag. So make sure you read the question.
Are we just submitting the code through Canvas, or is it going to be somehow through the Linux shell?
You're submitting a PDF file that has your code in it.
Okay.
So you're going to write your code in some sort of plain text editor. And then save it as a PDF and upload that. And then I'll sorry?
If you use Notepad on Windows, you can print and then print a PDF quite easily.
Okay, cool.
Windows 10. So.
Yeah, that's a good way to do it then. And Notepad is nice because it won't change your indenting, and it won't change uppercase to lowercase and correct spelling and all sorts of things that you really don't want to have happen when you're writing code. And then yes, the PDF gets uploaded to Canvas, and so the midterm area will have an upload option, and it will restrict to PDF files and just upload through there. It'll be set to allow as many uploads as you want, so you can keep uploading as you go in case something happens. And then the final upload before the deadline is your best final solution. So you should not have to print anything. The exam itself will be a PDF, and as long as you're comfortable looking at that on your screen, you should be fine. You shouldn't have to print it out or anything like that. And I think to print to a PDF, you do not need to be connected to a printer. I think you can just print to PDF.
Correct.
But again, try and nail that down today so that you're not fighting Windows issues tomorrow or things like that. So the exam is open note, open book. You can use the code you've written, the ODPs you've done, the programming assignments you've done, but that's it. So no other online resources. You're not allowed to use a compiler. You're not allowed to use a syntax checking, development environment, things like that. You can submit as many times as you want. It's marked for unlimited uploads, So, my recommendation is you finish a problem, upload it. You finish the next problem, upload it, right? Or, as you're getting close to the end, start uploading what you have so that, if you miss the timing by 30 seconds, it's not a big deal, because you've already uploaded most of your work before the deadline and so on. So yeah, it'll be set for unlimited attempts. And again, the exam will be during class time, so for this section it will be 10 o'clock to 10:50. And there was some confusion going on in Discord about taking it at different times, so the exam is during class time. The only time that changes for me is final exams. In final exams, the school publishes a schedule, and that's when the finals are. I recommend being in Zoom just so that you can hear like corrections or clarifications, but there's no technical reason why you have to be in Zoom. You can just download, look at the exam on Canvas and upload your answers. But if I mess up and I need to explain what a question means or change what a question says, if you're not in Zoom, you won't see that message. So I recommend being in Zoom. All right. Any other questions about the midterm?
I don't know if you answered this before, but are we allowed to do this coding in our basic Linux thing and then copy and paste it onto a PDF?
If you want to do this,
Type it.
if you want to do this like in VI or Nano or something like that, if you want to use just a plain text editor under Linux, that's totally fine. But I'm asking you not to compile the code to check for syntax, not to run it to see if it works, things like that. But if you want to do your typing in Linux, that's totally fine.
Although if you do it in VI, it's probably going to be a bit more of a pain to print the PDF.
Yeah, although if you have a Linux setup you're working in, there's a command called A2PS that will convert a text file to a PDF. Don't try to figure that out, tomorrow for the exam. But if you're already in a Linux environment and you've done this before, it's pretty smooth to make PDFs. But yeah, you can copy from VI. Just select your text with the mouse and then paste it into Notepad or whatever it is that you're going to use to make a PDF. And these shouldn't be programs that take 50 lines of code to write. They should be pretty small for the most part. If you have an extra time allowance, just take the extra time. So Canvas will say, the exam is due at 10:50, and if you submit it late, it will say it's late, but it'll still allow it. And I've got, records of who has extended time allowances and how long that allowance is. And so as long as, if you've got double time, turn it in within 50 minutes times 2, and that's good for an on-time recording. But Canvas won't stop you from uploading it, and just ignore the message that says it's late. All right, other questions? All right, let's talk about programming assignment 3, because I normally open these up on Friday, but tomorrow's our exam and it'll be the whole class period. So we'll talk about PA3 right now. So this is another game. It's going to be written in C. This is a high-low game. So there's a 3-page document. Oh yeah, send me an attendance ping. Some people have already done this, but send me an attendance note if you haven't already. So PA3 is a high-low game written in C. So probably you've played high-low before, right? You have two people, one person thinks of a number, the other person tries to guess it. So in this case, you're thinking of a number and the computer is trying to guess it. And it's going to make a guess, and you're going to say if that guess is too high, too low, or correct. And it's going to try to figure out what number you picked as efficiently as possible. So let's just play this. So we need a volunteer to think of a number and not tell us what it is, but to tell us if the computer's guesses are high or low. So who wants to think of a number?
A number.
Okay. So let's just play this straight. So there's a sample executable under temp PA3. So I should have said think of a number between 0 and 100. All right, you got one in mind?
0 and 100.
So we run this program. It says, welcome to my high-low game. You'll be asked to think of a number, blah, blah, blah. Respond with high, low, or correct. So it says, please think of a number between 0 and 100. Hit enter when you're ready. All right, are you ready?
Yes.
Okay, so it tells you how many guesses it's going to take. I will guess your number in at most 7 guesses. So guessed 150. So is 50 too high, too low, or correct?
High.
That's too high. All right. Is 24 high, low, or correct?
Low.
37.
Low.
43.
High.
40.
Low.
41.
Low.
Oh boy. Last guess. 42.
Correct.
Excellent. So that took the full 7 guesses. And we knew that it was going to get the right answer because if you had said 42 was too high, that's impossible because 41 was too low. And we already knew that 43 was too high. So, you know, the algorithm is sandwiching down the possible guesses. And it's eventually, you know, pinning it down to a range of one number, and that's what the number is. All right, so that's the basic game from 0 to 100 with no mistakes anywhere in sight. And there's other things you can do. So for example, if you don't type high, low, or correct, it will say, you know, please enter H, L, or C. And whatever you type in, right, it should insist that you type H, L, or C. And then it'll make a new guess if it's high or low, or it'll thank you for playing if it's correct. And unless you cheat, there's no way to beat this game, right? If it says it'll get your number in 7 guesses, it'll do it in 7 guesses at the most. So that's one thing. The other thing is you can specify an upper range. So we can say, think of a number between 0 and 1,000,000. And it will get it in 20 guesses. All right. The third thing you can do is you can specify a different range. So we could say, let's think of a number between 500 and 700. And it'll play that game with you. It'll try to guess your number between 500 and 700. And it'll do that in a few guesses. All right. If you don't put any arguments on the command line, you're playing from 0 to 100. If you put a single number, you're playing between 0 and that number. And if you mess up, if it's not a valid integer, it just tells you what you should be doing and it exits. So you either have to say main or main with a high value or main with a low value and a high value. If you do something like this, that's certainly an error. If you have 2 arguments but they're not both integers, that's an error. If the second number is not bigger than the first number, that's an error. But as long as the second number is bigger than the first, you can play between that game. So this is a silly high-low game. It's thinking of a number between 100 and 101. And it tells you it'll take 2 guesses. So 100's too low, that's correct. All right, that's oh yeah, earthquake drill. I was going to talk about earthquakes. So yeah, that's the whole high-low game. All right, I decided not to ask people to duck and cover for the earthquake drill today because I think we're all like kind of stressed out enough from 2020 and 2021. How many people here have been in an earthquake?
Technically, yes.
I slept through one.
Yeah, that seems to be what happens to a lot of us.
Well, one day, the big one will be here.
Yeah, it seems kind of inevitable. So yeah, I lived in San Francisco, and there's lots of little earthquakes out there, but most of the time they don't feel like much. There was one I literally thought someone was pushing like a large cart of copy paper down the hallway outside my office because the floor just kind of like had that vibration sound to it. It turned out it was an earthquake. So yeah, so if there is an earthquake, there's things you're supposed to do. So if it started, suddenly drop and cover, right? Get underneath something solid, and you're basically trying to stop things from falling on you. And so protect your head, hold on, because if it's a big earthquake, things will be moving around and shaking. But if you've got like a table or a desk or something you can get underneath, that's your best bet. As soon as it stops, get outside, get away from things that can fall. And so at Clark, when we're in person, we practice this. We go under the desks, and it's usually pretty disgusting. But it's a good thing to practice because when it actually happens, if it's not muscle memory, it's like, oh, cool, it's an earthquake. Let's see what's going, and you go over to the window to look and see, and that's not what you want to do. So yeah, it's a definite thing to be aware of, and there's fault lines up here in San Francisco. There's tons of fault lines. The biggest quake I was ever in was actually in Virginia, which is really weird because you don't get a lot of big quakes out there. 2012, 2013. Do you remember a tremor in 2012, 2013 in Vancouver?
It was between like 2011 and 2015. I don't
Oh,
know.
okay,
Exactly,
okay.
But that was what the pattern started telling me.
Yeah, yeah. All right, so yeah, if you're not familiar with earthquake rules, go ahead and review the basic guidelines. Of like, get underneath something, hold on, take cover, and then when the shaking stops, get outside and try to get clear of things that could fall on you. And that's the main danger in these is things toppling over. 6.4 in Cali in 2019. Yeah, that's pretty big. Are you familiar with the Richter scale?
An exponential scale of earthquakes.
Yeah, so each level I believe goes up by a power of 10. So a 7 quake is, significantly more powerful than a 6, and a 9 is like, 1000x beyond a 6. So the lower numbers, 2.2, 2.3, you might not feel, but when you get up to a 5, it's quite a few times more significant. All right, so back to PA3. So that's how the game plays out, right? You either play the game between 0 and 100, or you can put arguments on there, and the same error processing we've been doing since we started talking about C. So if you're looking for 3 command line arguments, for 2 arguments, right, 2 integers, make sure they're exactly integers. Make sure the first one is smaller than the second one, and so on. If you have too many arguments, that's an error. You can't have too few, because if you don't have any arguments, then you just play from 0 to 100. And once you're playing, just do error checking. Make sure that they're typing in exactly HL or C. And your game should, detect when cheating is happening. So I've said that 24 was too high, but then I told it that 23 was too low, and it's saying, well, that's a problem. Maybe you forgot your number. All right. So all of this is spelled out in the assignment. So this is a 4-pager. And it's just all the details written out for what we've just seen and said. But the program is written in C. It's a game of high-low. This is how you run it. Your program has to be called main, and you run it either with no command line arguments, 1 number, which is an upper range, or 2 numbers, which is a lower and upper range. And there's some examples. And then in the beginning, it should say, please think of a number and hit enter when ready, right? Don't start guessing until the person hits enter. Give them a moment to think of a number, and when they've got a number in mind, they hit enter, and then you can go ahead and start making guesses. So you begin by telling them how many guesses you're going to need, and then make a guess. So say guess number and tell them what the guess number is and tell them what your guess is. So like, you know, guess number 1, 50, guess number 2, 24, guess number 3, 11, and so on. And if they say high or low, make another guess. If they say correct, game's over, you can thank them for playing and you just exit. If there's cheating going on, if they've, you know, you've pinned their number down to it has to be this number and they say it's not, then there's a problem. You can say, you know, something's wrong with your guesses, with your answers, goodbye. Alright, we'll go through the algorithm in a minute. And it's a pretty straightforward algorithm, but it's very cool. Predicting the number of guesses, we'll talk about that in a minute too. Sample executable /temp/PA3. Alright, that tells you how the game's supposed to behave. Other program requirements. So this is where you definitely want to pay extra attention. So the way you write this program is critical to the grade. Okay, we're going to break this into functions, and I'm going to specify a number of functions here that you have to create that have to do certain things. Beyond that, you can make other functions if you want. You can put everything else in one file and so on, but you need to have these pieces. Alright, I want a file named intro.c which contains one function, which is a void intro, no arguments, which prints out the greeting, the hello message, the basic instructions in the beginning. And so on the top of your main program, you'll call intro. Alright, I want a file named predict.c containing a function, integer predict, that takes a pair of integers, low and high, figures out the maximum number of guesses you'll need to guess the number, and returns that as the function value. So that's going to be a function by itself. Also a function named getAnswer.c, which will contain one function called getAnswer. Takes no arguments, returns a character. And the return from this should be either the characters H, L, or C. And this function should, you know, ask the user high, low, or correct, and get an input from the user and figure out if they typed exactly H, L, or C. If they did, return that character. Otherwise, print a message saying, you know, please enter H, L, or C, try again, and so on. So your whole loop for doing the input from the user, all of that goes in this getAnswer function. And then a main.c, which is your main game program. So that's the thing that's going to have your integer main, argc, argv, and is going to call these things along with whatever else needs to happen. So your main program is going to call intro. Yeah, I would say do not use recursion if you know what recursion is. You can do it, but it's not going to save you a lot, and it sometimes makes it harder to do some of the things you need to do. So your main program can call intro. That can be the first thing it does. Well, the main first thing it can do is try to figure out if your arguments are correct. So parse your arguments, and you could put that in a separate function. I'm not requiring that, but you know, like we did in an ODP and some people did in PA2, you could pass argc argv to a function that tells you whether or not they're legal and sets up, you know, the low and high range. So you check your arguments and then call intro to print that message, and then wait for them to hit enter, and then call predict and say, you know, I'm going to make your correct guess in, you know, at most this many tries. And then use this algorithm we're about to go through to make a guess, and call the getAnswer, and if they say high or low, adjust your guess, make the next guess, and so on. If they say correct, the game is over. Alright, I'm also going to want a main.h that contains all of your function prototypes, right, for the intro, predict, and getAnswer functions, and anything else that makes sense to put in there. If you use structures, put the structure definition in main.h. If you have number sign defines, put those inside the main.h. And then include main.h in all of your programs, all your files. You can have additional .c files, additional .h files, and so on and so forth. Totally up to you. You also have to have a readme.md file. This is where you're going to put your name, class, date, description of the program in your own words. So that's a whole readme. And then you're going to write a make file. We'll talk about make files Monday. But this is this thing we touched on the other day where you can basically say make, enter, and it'll recompile things and build your executable, which is called main. And we'll talk about this. I'll give you a sample template for a make file, and we'll actually do this with some code. All right, and then submission, it goes into subdirectory PA3 under 224. Make sure your repo contains readme.md, the make file, and all of the .c and .h files. The goal being that if you go into that repository and you just say make, it should build the executable that's ready to run. All right, and then there's the grading rubric. So here's where points are being assigned. So I'm giving you specific point values for specific things. And this is important, right? You can have a game that actually plays high-low and only gets a few points on the assignment, because I'm grading you on how you implement the high-low game, how you structure it, and very specific requirements on how it starts, and so on and so forth. So .h files are not compiled .c files. .h files are files that include mainly function prototypes for us. So that, you know, since you're going to write a function called intro, in the beginning of main you would have to say void intro paren semicolon. But instead, this is going to go in a main.h file. And in the top of main, you'll include main.h. So we'll talk about that next week. So grading, executable has to be named main, that's worth 5 points. If you run it with no arguments, it should play from 0 to 100, that's worth 5 points. If you use one argument, it plays from 0 to that argument, that's worth 5 points. 2 arguments, plays between those, that's worth 7 points. Perfect error handling for the command line arguments, 7 points. Any mistakes in how you handle errors, you don't get any of those 7 points. All right, and greeting the user in the beginning and telling them what range you're playing with, that's worth 2 points. So that's just, you know, please think of a number between 100 and 200, and welcome to my high-low game. So that's your 2 points there.
How are you doing the hit enter when ready thing? Can you type in other characters?
I think you can type in other characters, that's fine. I'm just doing an fgets. So I don't care if you type extra stuff.
Okay.
The whole point of that is just so you don't, say, hi, welcome to high-low, is your number 150, before you've, let them, think of a number. Although that would be good, because then they'd probably think of something close to 150. Alright, so greet the user in the beginning, tell them the range, wait for the user to think of a number and hit enter, that's 3 points. Tell them the prediction for the maximum number of guesses, that's 5 points. For each guess, say, this is guess number 5, colon, is your number 23, right? So that's 5 points. Using the algorithm correctly, which means, going in the middle of the range each time that we're going to talk about, and responding correctly when they type high or low, that's 15 points. Making sure that if they don't type HL or C, you ask them to try again, you don't count it as another guess, and so on. And if they do type C, you recognize that as correct, and you say the game's over, thanks. Detecting cheating, 10 points. Breaking it into these pieces that are described up here is worth 15 points. And having a good makefile is worth 10 points. So if your code does nothing except have these pieces, and they compile correctly, and it's called main and so on, you get 10 points for the makefile, 15 points for breaking it into pieces, and 5 points for having your executable named main, right? So there's 30 points without having to actually write any code, right? But those are important 30 points. On the other hand, like I said, it's possible to imagine a game that plays high-low but only gets 10 out of 100 because it doesn't do all of these other things. Alright, so let's talk about the algorithm. Any questions on that so far? Alright, So let's talk about the algorithm for playing high-low. So let's just assume we're going from 0 to 100. This is the default game when you run with no arguments. So you're thinking of a number between 0 and 100. You know, one way to play this game is to guess, is your number 0, is it 1, is it 2, is it 3, is it 4, right? That doesn't work so well if they, you know, thought of the number 100, because it's going to take you a lot of guesses to get there. So what you do is you pick a number right in the middle, and you say, is your number 50? And if that's too high, then we're going to guess a number smaller than 50. But here's the thing: if we guess, so let's put our numbers out here, 0 to 100. We say, is your number 50? If 50 is too high, guess what? We don't have to think about any of these numbers anymore. And we don't have to think about 50. We know that anything from 50 on up cannot be your number, because if 50 was too high, 60 is going to be too high, 70 is going to be too high, right? So we've changed our problem to think of a number between 0 and 49. And so we'll cut that in half. Well, we won't guess 24.5, but we'll guess, you know, 24 or 25. And if the person says that's too low, well, now we know that it can't be any of these numbers. And so now we're thinking of a number between 26 and 49. And so with two guesses, we've simplified our problem to, you know, trying to guess one of 24 numbers now. So originally we had 100 numbers. After one guess, we had about 50 numbers. After a second guess, we've got 24 numbers. So we're dividing the problem in half each time we make a guess. And this is an example of a general class of algorithms called divide and conquer. And the idea of a divide and conquer algorithm is you take an original problem, you turn it into a new problem, which is simpler. And if you can turn it into a new problem that's a lot simpler, right, you can get down to a doable problem in just a few steps. And so a lot of problems have algorithms that exhibit this kind of behavior. You can basically cut the problem in half, or maybe in a third or a quarter, and throw away a bunch of the possible solution space and work on a simpler problem. And so in this case, with this high-low algorithm, we're cutting the problem down in half each time. And so if you start off with 101 possible answers, right, 0 through 100, and you keep cutting that in half, you can only cut it in half so many times until you get down to one possible answer. And so if you get down to 24 and you know, approximately 12, 6, 3, 2, 1, something like that. So the approximate formula will be the log base 2 of however many possible answers you have. Log base 2 of a number tells you how many times you can cut that number in half before you get down to 1 or smaller. So log base 2 is 6 point something, so 7 guesses will suffice. And if you go from 0 to 1,000, 10 times the range, it's only going to take you 10 guesses. If you go 0 to 1,000,000, which is 1,000 times the range, it only takes you 20 guesses. You are allowed to use math.h. If you play 0 to 1,000,000,000, it's 30 guesses, which is a whole lot better than you know, 1,000,000,000 guesses, which is what you might do if you just sort of randomly picked numbers. So 30 guesses to pick one of 1,000,000,000 possible numbers, that's pretty good. And this is, you know, a kid's game that you play for fun, but this is actually a key concept in a lot of computer science. The idea of a divide and conquer algorithm, right, comes up a lot. But this idea of splitting your space in half and working with one half or the other. This is basically the essence of how something called a binary tree works. And in 222, when we talk about data structures, about halfway through the course, we'll start talking about binary trees. And what we'll be doing will effectively be teaching a computer how to play high-low in order to search for something. Because what do computers do in databases? They search for things. You make a query and you want to pull out information that matches something, well, it's got to search. And this simple high-low algorithm is something we can use in a lot of search problems. Alright, so the implementation of this algorithm is the following. We always want to have a pair of variables in mind, low and high, where low is the lowest possible number they could be thinking of, high is the highest possible number. Okay, so your range is from low to high inclusive. So if we're starting off the game, we would set low equal to 0, and we would set high equal to 100. And then your guess is always whatever's in the middle, low plus high over 2. And we want to work with integers. And my suggestion is just let things round however they round. Don't try to round them yourselves. So 0 plus 100 is 100 divided by 2 is 50. That'll work out fine. That's a cool light show. But if low plus high is odd and you divide by 2, don't try to do anything to it. Just do the integer division and it will truncate and work out great. Alright, so you find your guess in the middle and you ask the person, is this your number? Alright, if guess is too low, then you want to set low equal to guess plus 1. On the other hand, if guess is too high, set your high equal to guess minus 1. If guess is correct, the game's over. Thank them for playing, you can gloat a little and stuff and just exit the game. But this right here, you gotta do this, and you gotta do this. And there's things close to this that may work sometimes, but will inevitably not work, right? If you set low equal to guess, sometimes it's hard to end the game. If you set your guess to low plus high plus 1 over 2, sometimes you'll miss a number, and so on. This will work, okay? Guaranteed, if you do it like this, this will work. So set your guess to low plus high over 2. If the guess is too low, change low to guess plus 1. If the guess is too high, change high to be guess minus 1. So that's what this spells out here. And then, you know, after you've changed low and high, go back up here, make a new guess, using that new value of low or high, and then go on from that. There is a hand up in chat. If that's a question, go ahead and ask the question. Sorry. If that's left over from who's been in an earthquake, then I won't worry about it. Cool. Alright, and then cheating. Cheating happens after you make this change. See if low is bigger than high. So anytime that you change low or high using this algorithm, run a little check, see if low is bigger than high. If it is, then something went wrong. You can call cheating and exit. If low is equal to high, that's totally okay, right? That might just mean that you got it sandwiched down to one possible number that they were thinking of. That's fine. Don't call them a cheater yet. But if after making these adjustments, either this or this, you find that low is bigger than high, you know the game's gone on too long. And you can tell them that and exit. Alright, questions about that? Either the gameplay or this basic algorithm for playing out the game. We'll talk a little bit about Big O maybe, but really in 222 we get into algorithms and Big O performance analysis and things like that. But the way that applies here is basically divide and conquer is basically a log n kind of operation. If you have, you know, a million possible things you're searching for one out of a million things, it takes you twice as long as searching for one out of 1,000 things, right? That's typical of something with logarithmic performance, and that's really nice, right? We could go up to 1 trillion things and it would take us 40 guesses instead of 30. And if you can search 1 trillion items to find something, right, in only 40 operations, that's pretty good, right? Imagine having 1 trillion CDs and looking for one particular CD. Well, if you alphabetize them, you can do it in 40 operations. If you don't alphabetize them, you got to pull 1 trillion things off the shelf and hope you find it. All right, so the other detail is predicting the required number of guesses. So the number of guesses is 1 plus the log base 2 of 1 plus high minus low. All right, this is just a formula you can take on faith, but you want to calculate this using doubles, and when you're done, just assign it to an integer. You know, integer number of guesses equals the result of all of this. But to do the log base 2, you need to have a double. So treat your high and low as doubles. You know, do high minus low, add 1, pass that to the log 2 function, and then add 1. And if you do a manual page lookup on log, you can see log does a natural logarithm of x. And so that takes a double and returns a double. And if you want to do log base 2, log base 2 of x equals the natural log of x divided by the natural log of 2. So built-in math library doesn't have log base 2, I don't believe. But just take the natural log of x divided by the natural log of 2, that gives you the log base 2. And that works for any base, by the way. Alright, so other questions about this? You've got a sample executable, so you can play around with that. I'm not super picky about wording, so you know, please think of a number between 0 and 200 and hit enter when ready. It doesn't have to be exactly that wording, right? I will guess your number within 8 guesses. Doesn't have to be exactly that wording, right? But I want you to wait for the person to hit enter. I want them to see the low and high range that was specified, and after they hit enter, I want you to tell them how many guesses it's going to take at most. And then make sure that each time you make a guess, you show what the number of the guess is and the actual value of the guess. So that, you know, as somebody's playing the game, if you said you're going to, you know, take 7 guesses or fewer, you can see how they're doing. It's like guess 6. Okay, you're only going to have 1 more guess left after this. That kind of thing. This is one of these games where you're welcome to take your executable and have other people try to play it. right? Or you can try to break somebody else's executable, and that's good practice, right? This gets around the idea of, you know, you've thoroughly tested this with the same 5 test cases 1,000 times and it works great. But what about test case number 6 that you haven't thought of? And somebody else might come along and try that and say, hey, you know, your code breaks when you do such and such. And that's good. You'd rather have a classmate figure that out than have me figure it out. So I'm okay with people running each other's programs, just, you know, as usual, don't share the code itself. Make files we'll talk about on Monday, because that's a whole separate topic, but it's a pretty easy thing to set up, but you don't need that to get started on this, right? And so how do you get started? As usual, I recommend building up your program in pieces. So start with, you know, just play from 0 to 100. Forget about command line arguments, right? Forget about error checking. Forget about predicting the number of guesses. Make it easier on yourself. Just, you know, ask the user if their number is high, low, or correct, and just do this. You know, start off with low equals 0, high equals 100, and make a loop. Find a guess, tell them what the guess is, ask if it's high, low, or correct. If it's low, do this. If it's high, do this. Go back up and do this again. And just get the core of something that actually plays the game, makes guesses, gets to your answer efficiently. Get that working. That's a lot of fun to have working, and then you can hardwire it to play from like 0 to 1,000,000 and see that it gets your answer really quickly. Right? And then you can start, you know, breaking it into functions, and you can start adding on layers of detail. You can start error checking when they say HL or C. You can write your predict function and tell them how many guesses it'll take up front. You can throw in the cheat detection and so on and so forth. But get something up and running as quickly as you can, because it's almost always easier to enhance and modify and further develop code than to go from nothing to something. Right? And there's a lot of parts and pieces in here. And if you try to get all of those written before you've even compiled your code the first time, you're just going to end up with lots of errors, and if it doesn't work, you're not going to be sure where the problem is, and so on. So my suggestion would be, do a much simpler version of this first. Get the core, you know, heart of the game to work, and then start going through this and figuring out what you have to do to get 100 points out of 100 and build it up like that. You've got a week and a day. Right, it's due a week from tomorrow, 8 a.m. But if you work methodically, right, it should not take that whole time to get this up and running. And when you're getting close to submitting, right, go through the grading rubric and use this as kind of your final check. Do I have all the things that I need? All right, that's all we got for today. So I will see you tomorrow at 10 o'clock for the midterm. I'll be in Zoom. Canvas will open up at 10, and I'll see you there. I do not need a final attendance ping. You're good from the beginning of the class, so we won't worry about that.
Okay.
All right, see you all tomorrow.